From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
With the journey to trying to find higher quality materials, I had talked to a few filament makers, extrusion folks at the time. And again, this is 2012, 13, and no one was kind of a dedicated 3D printing filament maker. They were making, plastic welding rod, weed whacker line, and stuff like that, just other things, other profile extrusions. And they just thought, oh, well, we can just make it to the size that these 3D printer guys want and just sell that. And I think that's fine, except what they're doing is they're using extruders and running all kinds of materials through them for different customers and different products. And not that they were just trying to be cheap or not caring. It was just that for their products, for their normal products, the specifications and cross-contamination and stuff like that just wasn't as critical.
That was Michael Cow. Michael founded IC3D in 2012 as a 3D printer design and manufacturing company. IC3D is one of the first 3D printer companies to manufacture their own line of 3D printing filament in-house. For 13 years, Michael was a senior mechanical engineer at Honda R&D, where he earned several automotive patents and designed interiors for future products. Michael started his Honda career in 2003 after completing a bachelor's degree in mechanical engineering at the University of Oklahoma. While at OU, Michael led the Formula SAE team to design and build race cars for their annual collegiate level competition. Michael has also led the Honda team to redesign the interior of the Acura NSX. He joins the show today to talk through his journey as an entrepreneur and how IC3D is building a fully end-to-end materials and manufacturing company. Before we get started, head over to www.3degreescompany.com and subscribe to the podcast. Remember, you can listen to the show anywhere you download your podcasts, including Spotify, Apple, Amazon, or Stitcher. All right, Michael, thank you so much for joining the show today. Excited for the conversation. We got to meet in person a few weeks ago, or about a month ago now, at the American Makes TRX event when I was over in Columbus, where you're based. So welcome to the show.
Thanks for having me, Mike.
So I like to start a lot of these podcasts with folks that have awesome journeys like you to like just start from the beginning, kind of like where'd you grow up? What were you interested in? Like kind of where's the story start for you on your path to entrepreneurship and 3D printing?
Yeah. Wow. Okay. So I grew up in Oklahoma City. I was born in Los Angeles, but we moved to Oklahoma City when I was about 3 or so. And my dad and some of his brothers, their trade was auto repair. So they opened up a little automotive repair business there. And that's where I grew up just as a little kid. There's no daycare. It was just going out to the shop. So I got a lot of just hands-on experience, just mechanical kinds of things. We lived in an old house. So my dad was always fixing something, in the house. And so again, that was just more opportunities for hands-on. I think, thinking back, that was probably a lot of how I ended up being a mechanical engineer.
Awesome.
So then, yeah.
And so kind of, were you generally interested in kind of the mechanical stuff, or is like you saw kind of your dad and people around you every day, like working on stuff, and like you kind of just get kind of interested in kind of what everyone else is doing? Like, was it just natural as well to kind of pick up what the mechanical stuff and fix things and build it?
Yeah, that stuff definitely became really natural. I wouldn't say I enjoyed it as a kid. It was just something you had to do and just dirty and whatever. But then, I think I'd rather like play video games and do that kind of stuff, play with old computers. But then later, when I was trying to figure out what I wanted to major in college, it kind of came down to like robotics and stuff like that. That was what I was really interested in. And So some counselors were like, all right, well, there's some mechanical engineering in that, there's electrical, there's some programming. So it was fairly diverse, in the engineering world. I ended up finding a organization called Formula SAE. If you heard of that, that's a collegiate level race car design and build competition. At the time, it was about 140 schools globally, and so I did that for about 3 years. And because of my sort of auto repair and like parts knowledge and experience, that was pretty easy for me. But it was the first time I got a chance to do real design work, like designing completely new parts versus just replacing them. And it was also my first experience getting to work with a bigger team, managing like 40 people. Eventually, I was team captain, and just kind of found a knack for it. I felt comfortable. It felt kind of natural. Got some good feedback, and that kind of really drove me to like an engineering job in the automotive area. So when I finished school, this is about 2003. That's when I got a job with Honda R&D, and that's how I ended up in Columbus, Ohio.
So with that kind of group that you were leading, so you said you're leading about 40 kind of students to build these vehicles. Like, what were some of your early leadership lessons that you took away, or kind of learnings that you tried to kind of take with you even kind of as you're leading a company now?
Excuse me. Yeah, certainly lots and lots of lessons learned there. The biggest one is probably just putting the right people in the right spots, versus trying to do something yourself because it's maybe fun, but it might be like a critical area where someone's just better for it. And yeah, so I learned that lesson several times. So that's one of the things I feel like has helped me, in terms of working with other people.
And I imagine as a student organization too, like as a volunteer, right? Like you guys are all busy with your normal classwork and other stuff. And so some people are probably more motivated, like they're not getting paid, right? Like it's paid in pride, essentially.
Yeah,
so exactly. Like trying to figure out how to motivate people and kind of work on that spectrum of like, hey, this person's really motivated and is going to show up every day when you ask them to, versus on the other end of the spectrum, like they're generally interested, they'll help, but less reliable.
Yeah. So figuring out, how to motivate people, how to drive people, figuring out, really clarifying, what the why is for anything was super important. Certainly like you said, getting a bunch of college students to work really hard for free amidst all the the finals and dating and all that stuff, figuring out themselves, so building their friendships, and then people also dealing with other organizations and clubs, and again trying to figure themselves out. Definitely a challenge.
And what was the end result of that? Do you build a new vehicle every year, or is it like a cumulative thing that you kind of do over a couple of years and compete?
Yeah, it has to be a brand new vehicle every year. So most of the teams that were more mature would even start in the summer.
Oh, wow.
Having design meetings and stuff like that. And then, you sort of sooner school starts, especially when you start to get funding, and you have your, the finance person is able to really start doing stuff. That's when you start buying parts and things like that. And you're almost trying to, like, you're trying to design it as much as you can, but like finalize stuff as much as you can, as quick as you can, so you can actually start building things, and then getting time in the machine shops and all that stuff. And then you hope to get a car done, kind of early mid second semester, so you can actually test it, right? You don't want to go up to a race and a competition with an untested vehicle. Yeah. And even with that, you have to do a lot of reporting before the competition. So you're having to create a whole presentation, cost analysis, again, a big design review, prepare for a big design review for judges. So yeah. And then you
So,
go and the competition's like, like 70% of it's dynamic. So which means the car is actually moving, acceleration, skid pads, autocross, endurance, and then fuel economy. And then the other part's static, which is like a design review. Again, the cost part of it.
so after kind of graduating, you have all this experience kind of running this team, you go over to Columbus, you're at Honda to start. So what were you doing there?
So I worked for Honda R&D, and I had signed up with a seating group as part of the interior group, and just designing parts and for components for new Honda and Acura vehicles. So it was actually incredibly similar to the experience I had in the Formula SAE program. So that was actually really good. I encourage a lot of people who are kind of seeking this path to really explore that.
And so how does it work? And so, I mean, Honda's an enormous organization, right? Like there's Honda, Acura, but then all the other vehicles and motors that they make. And so what does the group in Columbus focus on, or kind of how did kind of part design fit into the broader mission or goal of the company?
Yeah. So so obviously the mothership is in Japan. Mm-hmm. And so like the main business office and engineering is there. Honda R&D Americas is kind of the second largest R&D office after that. And the Americas, it started off, I think, in maybe the 80s, and it was as a local office to localize things. So for example, they might do most of the Honda Accord in Japan, and then the Americas office would localize it. So maybe there are certain features that are more suited to Americans, or to sell vehicles in America. Sometimes there's like regulatory kinds of things and compliance, and it'd be that. But right now, Honda R&D Americas is mature enough that they are creating full platforms now. They might take an engine that was designed and developed in Japan, but everything else may be designed from the ground up in the US.
That's awesome. And is that around the time you got kind of some exposure to 3D printing, or where did the exposure first come on that front?
Yeah, so the first time I saw a printer was senior year of college, but it was, I don't even remember what it was. I just remember it used wax. There was a big jug of it that was red, and another big jug that was green, and it was broken. So I have not seen that run when I was in school. And I remember just in one of these manufacturing classes, just watching a video, and it was a quick blurb in this video. So I knew what it was, but when I started, pretty much as soon as I started at Honda R&D, 2003, I was designing little plastic parts, little injection molded parts, and my boss was like, "Hey, we just recently got a couple of 3D printers downstairs, we had a big fabrication lab." And he said, "Hey, you can get your stuff prototype." So I did. And at the time, the gentleman running the lab he wasn't not that busy, because nobody really knew he existed, because it's kind of a brand new capability, brand new lab. And so he had a lot of time, and he explained a lot of the ins and outs of the couple of printers that they had, and a super nice guy. And I was not so busy because I was a fairly new guy. And so I became sort of his evangelist on to the other engineers and designers to say, "Hey, we've got this service now, you can go get your thing printed for free downstairs." And so he would just take a lot of time to show me like the insides of the machine, the process, different materials, and he would just print all kinds of sample parts for me. And so I'd be like, "Oh, hey, print this, print that, print this, and hey, print this, but print this twice, but leave support material on the other side. Don't wash it out." and stuff like that. So it was kind of fun. So the next few years, it was just getting a lot of parts that I was designing made.
What was your favorite part that you designed?
Favorite part. It's hard to say. Well, eventually within Honda, I managed. I was project leader for the full interior for the sports car. It's called the NSX.
Mm-hmm.
So I guess as a whole, that was my favorite thing I did.
Did you get to drive it?
Yes. lots of time, because I was in charge of design of the interior, which includes like interior performance. So it included how the seats feel, for what the customer is going to do with it. And it's not a minivan, so I did get to drive it on a track a lot. And how does it feel when you corner? Like, what are your knees going to bump into, right? So we had to think about padding and some ergo and controls and things like that. So yeah, I enjoyed being in that spot, and it was fun driving that and pre-production prototypes and competitor cars.
That's great. And kind of, when did you make the transition to more of the entrepreneurial route? So Honda's massive company, and kind of you're in a pretty structured environment, I'm guessing, but kind of what was next?
So in 2011 was when I first discovered the desktop printer kits. The most popular one was MakerBot's. They had their cupcake and then the Thing-O-Matic. So my first personal printer was a Thing-O-Matic kit. And that was just a hobby, just playing with it. And then in 2012, or at the end of 2011, I learned about RepRap, the open source replicating rapid prototyper. And so I ended up, the stuff I was printing on my MakerBot Thing-O-Matic ended up being RepRap parts. And so in 2012, I just really got into sort of tinkering with modding and building RepRap printers. Specifically, there was one called the Mendel Max that was mostly made out of aluminum extrusion. So it was a hobby that just kind of went kind of wild, and I ended up building like 50 or 60 printers in my basement that year, and put them in local schools and sold them on eBay and stuff like that. And that's how I decided to start the LLC at the time, which is IC3D. So then like around 2013 and in 2013, I decided not to do desktop printers myself anymore, and I got into materials because the printer thing as a side job or side business, it was very difficult because there's so much going on, so much activity. But at the same time, with some injection molding background, I thought I was struggling to find high quality US made filament. And I said, how hard can extrusion be? And turned out to be a lot more complicated than I thought. But
famous last words.
My mind was like, yeah, exactly. And so I got into plastic extrusion again as a side thing, partnering with a bigger factory in 2013. And so around 2014, 15, I was sort of mentally checking out of the corporate world, and just didn't really see my future enjoying life in the big corporate company world. And at the same time, things for the IC3D were kind of picking up, and so I pretty much, and then I added a couple partners, Kimberly Gibson and Matt Organischak, around 2015, and we just started doing a lot of scheming and brainstorming of what this thing is, what kind of company, what kind of values and mission and that kind of stuff. And so pretty much made the decision mentally, at least in 2015. And the project I was working on, this NSX, launched in the summer of 2016. And the VIN number 1 rolled off the line and the next day I put in my 2 weeks. I just felt like that chapter was complete. I feel like there were no loose ends remaining, and that was it. Just haven't looked back.
And how did you link up with your two partners?
Two very different paths. With Matt Organishak, he was a customer, and then he had learned that I was in Columbus. He was buying my filament and learned I was in Columbus, and then called me up or messaged me, asked with a question to get help with his a component he was looking for his printer, and I helped him out. And then I noticed he was into rally cars. He was helping a local guy build rally cars and stuff, and I was a sort of a car guy, and so we met up, and then just kind of hit it off as friends. And he was at, I think, his final year or so in college, and trying to figure out what he was going to do. And he actually took a job in Ann Arbor for just under a year, but really wanted to move back to Columbus for several reasons. And one thing led to another, and that he became full-time at IC3, a partner. And then with Kimberly, also 2014, we met a few times at different events and things. And then towards the third time, she was also sort of exploring something new, a new path. And she had some 3D printing experience from like the business development viewpoint. And so she really wanted to give small business a try. She has a vast experience in the government world. And so, you partner, the kind of the golden rule of partnerships is you partner with people who share similar values but have different skills, right? And so that really defines the relationship I have with both Matt and Kimberly. Very similar values in life, but different skill sets for sure. And so we kind of all lean on each other, and it just felt right. So that's probably one of the luckiest things from my viewpoint when you're trying to like start a business or something, just finding good partners.
So can you talk a little bit about the kind of ecosystem of filament for kind of the extrusion technology? So you said initially that as you were thinking about kind of making your own, like that it was hard to find stuff that was locally sourced, quality was kind of sketchy. Kind of were those kind of the main kind of drivers for you, or like as you started to go down that path and taking pellets and extruding them, like what did you learn? Like what was the feel of the market that you got to learn about as you kind of dive in with your company?
Yeah, there were, so with the journey to trying to find higher quality materials, I had talked to a few filament makers, extrusion folks at the time, and again, this is 2012, 13, and no one was kind of a dedicated 3D printing filament maker. They were making plastic welding rod, weed whacker line, and stuff like that, just other things, other profile extrusions. And they just thought, oh, well, we can just make it to the size that these 3D printer guys want and just sell that. And I think that's fine, except what they're doing is they're using extruders and running all kinds of materials through them for different customers and different products. And not that they were just trying to be cheap or not caring. It was just that for their products, for their normal products, the specifications and cross contamination and stuff like that just wasn't as critical as it needs to be for 3D printing, right? And so I was trying to figure out why like random jams would happen, why random issues would happen, even with something that was like was like working for months and then all of a sudden not work. So after that, my conclusion was that kind of my hypothesis was like, okay, if these guys are not completely purging or cleaning the equipment between materials. Like if they're running polycarbonate and then after that they're running PLA or something, and they have a little speck of polycarbonate in the PLA, well, that's an instant jam right there. And so off of that hypothesis, basically I got two commercial grade extrusion lines and said, oh, I'm only going to run like these materials, like that have very similar. Only going to run materials that have this very similar melting temperatures, right? And that was it. And so, controlling other parts of the process, of course, but so we've been making filament for about 8 years now, with pretty good feedback from the community. But I guess, the current state of things, yes, the quality overall has increased, and I think you can find pretty consistent stuff now overseas, and because the demands continually increased, and that's fine. For us, the materials side is more than just making money from selling materials. It's about that vertical integration and that whole ecosystem for us. Having the ability to control materials and develop new materials, and then have a printing service that's mostly comprised of machines that we've designed and built, and controlling the outcome of that, and then being able to help customers with new applications with the understanding of both materials and machines, and that whole tuning has been really valuable. That's a big part of us getting the opportunity to work with the Army on this research project.
Mm-hmm. Yeah. And we'll get to that. I want to kind of dive into that a little bit more in a second, but kind of going back to when you started, you're doing kind of your own extrusion. So you need some sort of raw material, pellets and things like that. But typically those are sold by the truckload or the train load in many cases. Yeah. So was that a challenge at all? Like, did you have to, I know there's some converters or kind of middlemen in the industry that will kind of give you 5, 10, 100 kgs of material. But from my experience, like that's often very hard, like harder than getting like a silo full of pellets, right?
Yeah, definitely. So the unit of measure that we have to buy, we buy these pellets in is called a Gaylord, and it's basically a big cardboard box fits on a pallet, right? Yeah. And a Gaylord of resin is typically somewhere between, depending on the resin, somewhere between 1,500 and just under a ton, 1,500 pounds to just under a ton, and that is for sure small for a lot of these companies, but they're still fine. They're still fine selling it at that unit. In the beginning, when we were just starting, we would only order like one of these boxes every few months, right? Now we have them coming in, every other day or something. But people were pretty understanding. I think people were pretty like supportive of small business in general and willing to work with you. So, yeah.
And now, so you've kind of built out your kind of materials ecosystem. We talked a little bit about kind of the vertical integration, and you've got kind of going back to the very early days on the rep side. Kind of you've got a machine developing and kind of building out your further capabilities. So kind of what's kind of the vision for the company now? Is that really like that end-to-end vertical integration? We control the materials, we know the machines, and by definition, we can get kind of good quality parts out.
Yeah. Just to be honest, like just to be honest, in the beginning, we didn't really have a solid plan, and we didn't have like this like 20-step process.
You didn't have the MBA, the MBA deck of 10 slides, and this is going to be Hockey stick growth by year 3.
Right, exactly. No formal business plan. We just did the lean canvas kind of thing. We did like several of those, which which is which is awesome because when we look back at them years later, we're still like right on. We're still like on track for those. But yeah, we intentionally didn't accept any like VC monies, private equity, things like that. We just valued mental freedom to make decisions on where to go. So I would say just about 100% of like our decisions are customer driven, right? So it's just over the years, customers saying they need this, they have these kinds of problems, they, this and that. And that's guided the materials we make, the printers that we design and build, and just the stuff that we add to our facility. And that's just been a lot of fun. I think I'm not a researcher that just wants to find something novel to put my name on it or to put it on a shelf. I am pretty pragmatic. Like the stuff I work on, I mean, it needs to solve a problem. It needs to be helping someone, or I'm not really interested in it. So that's really guided how everything has gone.
That's awesome. It's so very refreshing. I mean, I've taken a similar approach in terms of my companies, and like started with zero in the bank account, and you kind of slowly build up, and gives you more freedom to do different things or explore other opportunities versus some of the external funding routes. And so as kind of that has evolved, like where are you guys at today? Kind of what's on your radar? There's some big trade shows coming up this month, and with Rapid and some others, but kind of what's really exciting you now, and what's kind of right in front of you?
Yeah. So it all comes down for us. It all comes down to applications development, really making AM useful to people now, like today. So we end up working with a lot of larger OEMs, big suppliers, like big automotive suppliers and things like that. Companies, factories that are manufacturing stuff now, doing a lot of either larger prototypes or jigs and fixtures or certain types of tooling, low volume production. We've done low volume production for even large companies, their first trial runs of stuff, wherever it makes sense. And so that kind of stuff is really exciting for us. So going back to applications, we're gonna be figuring out more applications for what we're doing within DoD. I know we'll talk a little bit about that later. The more certain materials that are coming up that we're working on have a specific function that we're excited about. Getting into releasing this 3D printer. That's sort of a medium-sized industrial printer. It's geared towards some very specific customers that we have in print service, to help them do their thing in-house. So again, not so specific, but it's all about like applications. And yeah.
And we were talking a little bit before we kind of started the recording about some of your DoD work. You got a SBIR going with the Army, to the extent that you can talk about it without having to kill me and get rid of the evidence of that. Kind of what's the idea there, or kind of even what's the story of like for this? I know there's a handful of people that listen to this that are running their own small business. Maybe just start with like, what's a SBIR? Like, how did you get involved in the process of pursuing that avenue of funding, and then maybe get into the actual topic?
Sure. SBIR stands for Small Business Innovative Research, and it's basically government R&D funds, specifically geared towards supporting small business, like exactly like the title says, small business. So it's so large government primes can't be the prime can't get SBIRs. You can partner with people with SBIRs, but small business. And the other focus is on commercialization. So So even though they're looking for new technology to use within the government, and I say government, not just DoD, because the SBIR program also includes um, NASA and NSF and stuff like that. Um, and I think like Department of Energy and Department of Ag and stuff like that. So it is government wide. Anyway, so it's not just them looking for a new technology. They want to make sure you have a really strong commercialization plan, that the results of this research, you're going to be able to make money off of it and sell, so make a product or service or whatever. Um, so uh, our our SBIR topic is geared towards 3D printed tooling, but specifically, they wanted to produce tooling for an overmolding process. Like if you think of electrical harness, like a cable, at the end, like even your headphones, right? The wired ones. At the end, there's a little kind of rubbery protective coating and a little flex thing. That's overmolding. So they mold over the connector, the solder joints, and the cable. And so they wanted tooling for this, but specifically, they didn't want to just use Ultim on a really high-end printer, on an expensive printer, and get this done. They specifically wanted to utilize the desktop printer infrastructure, right? That's already out there. So you can kind of imagine, see the value of that, right? So with the capabilities, if you develop capabilities for lower cost, I'd say a bit more rugged machines, then you can have that capability much closer to the actual environment where battles are taking place, right? And when you're talking about a multi-domain battlefield, from strategic, which is like at home, like in the U.S., to close, which is like out there, right, at the front lines. So the further you can push capability out there, the better, for all. And so the challenging part is not just finding a material that works for the application. It's finding developing material that works with a common desktop printer, that also meets the specifications for this manufacturing process. So in a nutshell, that's what our project is about. We were awarded our phase 1 in 2019, and then it was a six-month project. And then shortly after, we even though COVID happened, we were still able to submit our proposal, and things got a bit delayed, but we were awarded the phase 2 towards the end of last year. And so we're about a third of the way through our phase 2, which is, I guess to step back and explain the phases to folks who aren't as familiar with SBIRs or SBIRs. Phase 1 is typically like a feasibility, like get your feet wet, see how, let the DoD folks kind of get to know you, and see how it goes. So it's a feasibility phase. It's not that much money, relatively speaking, and it's only 6 months, which is relatively quick. But once you kind of get through that and can prove yourself as a company, of your legitimacy, and prove that the concept is good, then you can apply for the phase 2, which is a lot more money and a lot more time, and and you get to really do more kind of structured product development, engineering, that kind of thing. So you actually get a lot more funding to do a lot of testing, a lot of printing coupons and breaking them and collecting data and things like that. Things that are necessary, right, in order to come out with a product. And so that's what we're in. There's also a phase 3 that you can get, that from my understanding is not from the SBIR funding pot. It's it's usually funded by other kind of external means, and various branches of the military can kind of jointly fund a phase 3, and it's a lot about more applications development. So where can the research you've done fit in to other groups, and that also has a much larger, higher funding amount.
And did you propose the original kind of topic or kind of approach, or was this something that, hey, there's a bunch of topics that are released every year and it happened to overlap with what you guys were doing or thinking about?
It was a topic that was posted publicly, mm-hmm. And we did happen to know the TPOC, the technical point of contact, listed on the topic, and so that person's usually, again, it's publicly posted on there, and typically you can contact that person and have conversations before the proposal deadline. And so after some conversations and some clarifications, we did feel like this was really up our alley, because it was partly materials research, materials manufacturing, and then applications development. So, I mean, you've been over to our facility, so you can kind of, I mean, you know that, I mean, it was just, we were just legitimately in line with all that stuff, versus just a research lab, and again, the commercialization aspect we felt was pretty strong and legitimate, because we wanted this kind of material for our customers in print service and materials, right? Most of our customers are businesses, and they're making stuff. They're making fixtures and tooling and whatever. So it just seemed like a perfect fit.
That's awesome.
Yeah.
And so kind of as we look to kind of wrap up this conversation, hopefully we'll have more, and I'll see you in person at Rapid in a few weeks. I mean, what are you excited about for the next few months, and kind of your company or the growth of kind of you professionally in terms of what you're doing, building the team? Like what's exciting?
I think one of the most exciting things for us right now is the new 3D printer, Virago. And it's, we've been designing and building our own machines for a little over 5 years now, since the beginning of 2016. And for the most part, these machines have just been for in-house use to print a certain thing for a customer. And this printer is kind of maybe our 4th generation machine, and it's just taken a lot of lessons learned from usability, reliability, and things like that. And this is kind of the best machine that we've come up with lately. And so we set off trying to design a printer that we would want to build out our own fleet of, right? So this machine, we want to build out like 50 of these for our print service. There was no machine that we felt that we wanted to commit to in terms of like a cost performance perspective. And so we designed and built this machine for us, and then we decided we felt confident enough to share this with others. So that's why we made the decision to release it as a product this year. So we've taken it to a couple of shows earlier this year, taken it to Rapid. We've sold a couple on paper that we're delivering a month. So we're excited about that, and just a lot more conversations happening that we're excited about related to getting more of our machines out there, and also really excited about just leveraging the vertical integration and the ecosystem we've built, right? So, for example, not just selling someone a machine or selling someone materials or doing service, but doing really interesting kind of high value things like we can help you we can help you do 3D printing in-house. We can help you with multiple printers if you're trying to figure out production. We can help you produce maybe a specific material that you want to, and help you tune those profiles for the thing you're trying to do with your machine. If you're, since we're planning on having a fleet of these ourselves, you can do interesting things like, hey, if you're running production with our machine in-house and something goes wrong or something happens or you have a spike in demand, we can kind of shift that over to our facility, pretty quickly and not have much downtime for you, right? So stuff like that is, I think it's unique value. I think it's high value for certain customers, and those are have been interesting conversation points with some of our potential customers.
That's awesome. Cool. Well, Michael, thank you so much for joining the show today. I'm excited to see you in a couple of weeks, and everyone listening should stop by their booth at Rapid and check out all the cool stuff they're doing. So appreciate the time today, and we'll see you soon.
Cool. Thanks for the opportunity, Mike. Good luck. I'll see you soon.
Sounds good.